Welcome back. We are ready for lesson 2.5, U.S. Traditional Multiplication, Part 2. We will be able to use U.S. traditional multiplication to multiply multi-digit numbers by one-digit numbers. We will also be able to perform operations with multi-digit whole numbers and with decimals to the hundredths. Starting off, taking a look at this problem over here to the right, 264 times 7, it was solved using the U.S. traditional multiplication. Take a minute and think about how the strategy works. Hopefully you remembered that we start over to the right and we take it times the ones place. If there's any tens, we carry those over. Then we multiply it by the tens place, add the tens. If there were any hundreds in that answer, we move that over, and so forth. So you see 264 times 7. 7 times 4 is 28. 6 times 7, 42, plus 2 would be 44. And 7 times 2 is 14, plus 4 was 18. So you get 1,848. So this is the same algorithm to multiply a one-digit number by a two-digit number. Let's take a look. Multiply the ones. Write the 8 in the ones column below the line. Write the 2 above the tens column. So think about that. How's that step similar to multiplying a one-digit number by a two-digit number, and how is it different? Okay, so hopefully you're noticing patterns in the steps of the U.S. traditional multiplication. So take a look at step 3 here. Multiply the hundreds. So before we were just had ones and tens places, now we're moving over to the hundreds place. So instead of having a two-digit by 1, we have three-digit by 1. We just keep moving over place values. So you can use the patterns you notice to help when multiplying larger numbers, like using U.S. traditional multiplication. So let's review this example below. We have 2,192 times 3. Our first step is to multiply the ones. So we would multiply 3 times 2, or 3 times 2 ones. We get 6 ones. I'm going to write that 6 in the ones place, or in the ones column. Since there are 0 tens, we're not going to write anything above the tens column. So sometimes there's no need to write an extra digit above the columns because there's no extra tens, hundreds, or thousands to add up in the next step. But if we take a look at step 2, now we're going to multiply the tens. We're going to take 3 times 9 tens is going to give you 27 tens. There are no tens to add from step 1, so it's just 27 tens. That equals 2 hundreds and 7 tens. So you're going to write the 7 in the tens column below that line, and you're going to carry the 2 over to the hundreds because we know that 27 tens or 20 tens equals 2 hundreds. So we can see we have 2, 7. Moving over to step 3 and step 4, we're going to see we are now taking the 3 times the hundreds place, and there's only 100, so it's 3 times 100, but then we have to add those 200s here, which gives us 500s. And there's no thousands, nothing to add over on the top of this column, so we can see we have our 27 here, and then we have the 3 with the 2 equals the 5. And then finally, step 4 here, multiply by the thousands. So we're going to take 3 times 2 thousands, which gives us 6 thousands. There was nothing to add on. So we can finally see that 2,192 times 3 equals 6,576. So you may use your student reference book on page 102, but I'd like you to pause and try out using U.S. traditional multiplication. It's just, again, like doing the 2-digit times 1-digit, but now we're extending it to 3-digit and 4-digit times the 1. So pause the video, try these 2 out on a slate or a piece of paper, and then come back when you're ready and check your work. All right, so by now you should have done 423 times 3 and 2,681 times 5. You can see I've started out by 423 times 3. I took 3 times the 3 ones, and I got 9 ones, nothing to carry. Now I'm going to take 3 times the 2 tens, which is 6 tens. Again, still nothing to carry. And then I'm going to take the 3 times the 4 hundreds, which is actually 12 hundreds. So I'm going to write that 12. And I see that the answer is 1,269. Now I'm going to come over here and we will do 2,681 times 5. I'm going to use that same method. We're doing the US traditional. So I'm going to do 5 times 1, or 5 times 1 ones is just 5 ones. 5 times 8 tens is 40 tens. So I'm going to write the 0 in the tens place and carry the 4 to the hundreds because it actually means 400s. 5 times 6 is 30, plus that 4 is 34. So I'm going to write my 4. I'm going to carry my 3. 5 times 2 is 10, plus 3 is 13. I know that's the end of it. So I'm going to write the 13, and I see the answer is 13,405. Okay, so now you can look at Student Reference Book, page 325. And remember, you can access that on the Everyday Math website. Multiplication, top it, larger numbers. Here are the directions, though. This can be found in the SRB, but it's also found the directions right here. Step 1, you want to get a deck of cards, okay? And you just want to use number cards. So if you don't have number cards, you can make number cards. You want to have numbers 1 through 9 and have multiple copies of those numbers. So you could take a sheet of paper and fold it into 9 or 8 sections, cut those, basically make yourself your own little number cards just from a sheet of paper. It doesn't have to be anything fancy. Shuffle that deck and place it number side down on the table or on the floor, wherever your surface is. And you'll want to play this with another person. So each player is going to turn over 4 cards. You're going to choose 3 of them to form a 3-digit number, and then the other number is going to be what you're multiplying it by. And then you carefully consider how to form your 3-digit numbers. For example, 462 times 5 is 2,310, while 256 times 4 is only 1,024. Because the player with the largest product takes all the cards. At the end of the game, or the game ends when there's not enough cards for every player, and the player with the most cards win. So you can also do this using 4 cards to make 2-digit numbers to multiply. So you could do 2 digits times 2 digits if you want a little bit of an extension there. If you're feeling like 3 by 1 is getting pretty easy and you want to extend your practice, do that variation. And take some time to play at least 1 round of multiplication, top it. A suggestion for you to get some more practice is HomeLink 2.5. You should have this in your HomeLink book. And it's 2.5. At the top, you can practice the multiplication, top it, larger numbers for numbers 1 and 2. And then at the bottom, there is some more practice of using exponential notation, some things we've been talking about. So you can write 100 as exponential. You can write 100 million, 10,000, and 1,000. Okay? So take a look back through the slides, through this video, try out HomeLink 2.5, and then move on to your independent work.